Tuesday, right? It's Tuesday. Are you keeping track of the days? I know at our house we have to remind ourselves of what day it is. So it's Tuesday, if you weren't aware, March 24th. And if you didn't know, I loaded a bunch of worksheets on Google Classroom. I sent out a remind to that effect. I think I can go, I'll go through a couple of things on some of those first worksheets right now, just to get some review practice for Unit 1 here. Zach's working on getting them up on your screen for you. You already should have them through Google Classroom. But before we start, do we have anybody on, Zach? Do we have any questions to start us off? Just trying to maintain the calm. Zach, just get out of my just close my whole internet thing. I'll get out. I can get back to all the places I was. I have like 1,000 tabs open on my internet browser, and I'm trying to send an email to him of the documents for you. And anyway, do we have any questions popping up? No. So one of the things I sent you was Adrian Dingle on his website. Just search Adrian Dingle. He had a review session today over equilibrium, or what he calls equilibrium. He is originally from the UK. And it was a good session. Good news for you is everything that he thinks is important, everything that he summarized, I absolutely went over with you multiple times. So bad news for you would only be if you'd never paid attention. So, but everything that he shared, I have shared with you. He just shared it in a one 40-minute session. Also, of course, it came up about the how the test has changed, that there's going to be 2 test dates. One of them is going to be right around the 7th, and then another one will probably be a couple of weeks later than that. You could take either one, but it's going to be online at home, that kind of thing, 45 minutes. His concern, which he has voiced from the beginning, which is what we're all concerned about, is how we're going to avoid people cheating. Now, of course, it's not our problem, it's the College Board's problem, and so forth. But definitely not an ideal situation. We still don't know that the College Board is going to cancel the test, so we're still at the idea where you can get a refund if you want, or you can take it online. So again, as far as I'm concerned, as far as my stuff is concerned, my biggest way of communicating with you is through Remind, and then you should be on Google Classroom now that I've set that up. I put on there several worksheets reviewing Unit 1. You just do as many, like if you pull those up, look at them even before you print them off, if you have access to a printer. And I need to talk through who needs, if you don't have access to the internet, obviously I'm not talking to you if you don't have access to the internet, but if you have friends who don't have access to the internet, of course we've got to get all that sorted out and get them resources. But it can't be through me directly in terms of, they're going to have to get it through the CFISD channels. It's going to take a while. So regardless, if we just talk about the online access, again, it's Remind, it's Google Classroom, it's you getting sessions directly from Adrian Dingle, it's you getting sessions starting tomorrow through the College Board. So your best resources continue to be each other, and I'm just making you aware of College Board website and now Dingle's website. You're not going to be able to access all the stuff that I can access, but he's giving you he's giving you some free review sessions. And he did the first one today on what he calls equilibrium. So, do we have any questions? How many people are on? What's our status? 8. Yeah. So go ahead and pull up the first one, 01A. You see when it says 01A? 01. This one? Yeah. Pull that over there for them. So this is way back to Unit 1. Now, when we get started to talk about units, things can get confusing because my units are not College Board units, and I was condensing units, and blah, 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 blah. So just know that whatever I'm going over now in these review sessions is going to be on the test. It is fair game for stuff you can see on the test. Now, these worksheets are not AP style questions necessarily. So they might be, they might not be. But this is the content that you need to review. So I'll go over a couple of things with some of these worksheets, but then I'm going to say you complete as much of it as you want to complete, and then I'll have a Q&A session later in the week where we can just literally go over the questions that you have on these. I can, getting the keys to you on all these will come later. I don't have all of those for you yet. So, all right, number 1 on worksheet 1, a sample of germanium is found. So actually, Zach, if you could also, for me anyway, pull up a tab with a periodic table, because I'm going to need values. And normally in my classroom it'd be on the wall, but we have number 1, sample of germanium found to contain 9.70 times 10 to the 23rd atoms of germanium. How many moles? So, yes, this is simple, but let's just go and review here. So we have this many atoms. So if I have 9.7 times 10 to the 23rd atoms, then I know that for every 1 mole of germanium, there are Avogadro's number, or 6.02 times 10 to the 23rd atoms. If I had 6.02 times 10 to the 23rd atoms, I would have a mole. So obviously I have more than a mole. But since I have times 10 to the 23rd and times 10 to the 23rd, I don't really have to put those in my calculator. You can reduce your calculator work, and you're really looking at 9.7 divided by 6.02. So that's all that is 9.7 divided by 6.02. That's going to be your moles of germanium. So basically, 1.5. So that's number 1. What is the mass of the sample? We can continue the line here in our, those of you who you may use a different method, but a different format, but I use dimensional analysis. And in 1 mole of germanium, there are so many grams, okay? So for that, I got to look at this table over here and look at germanium, and I see I need a different table.
Oh.
So you need a table that has masses, not just numbers. Some of these. So just go ahead and give me images, and that's fine. Let's do that one. And so germanium is going to be 72.631. So this is going to be 72.631. So you're going to take 9.7 divided by 6.02 times 72.631 and get your answer there. Okay. And question two, how many W atoms? He's using very obscure
table.
No, I don't even think that is. I think so. 0.43 moles of W. Okay. In every 1 mole of W, how many? Of course, again, it's 6.02 times 10 to the 23rd atoms. And then what is the mass of W? Do you see just W on it? I haven't even used that in any example. Oh, there it is, number 74, tungsten. What is that? 183?
183.84.
183.84. It's going to be here. 180. $183.84 grams. Okay, so that's how you would set up A and B for number 2. And that question 3 would be very, very similar then. So if you scroll down on this one, to the next page, see what they got there. So that's more of the same. Let's go to question 5. Five moles of a binary group. So I haven't done these yet. I'm doing this for the first time with you here. So number 5. 5 moles of a binary group 2 oxide. So this is going to be some metal X with oxygen. And because it's group 2, if you look at your periodic table, because it's group 2, that all of those have a +2 oxidation state. So if they have a +2 oxidation state and they're mixed with oxygen, which has a -2 oxidation state, it's 1-to-1. It's a 1-to-1 ratio. 5 moles of it have 521 grams. Okay, so we're going to say grams per mole. So 521 grams have 521 grams of XO make up 5 moles. Okay, so obviously that's very close to 100. So we're going to get 521 divided by 5, and we get 104.2. 104.2 is our grams per mole. So that's our molar mass. What do we want here? Okay, so we know that this is the molar mass of this, and we know that the oxygen is 16. So 104 minus 16 is going to be 88. Is that right? check my math there. Is that right? 104 minus 16 is going to be 88.2. So I was right, 88.2. So then we look for the group 2 metal that's close to 88. And that's going to be strontium. Is number 38, is that 87.62?
Yeah.
Okay. So this is very, very close to the molar mass of strontium. Then it says how many ions are in the sample. So we have back to, if we do 88.2, so in 5 moles of this, we know we have 5 moles of XO, or in this case SRO. We have 5 moles of SRO. And it wants ions. So 5 moles of SRO. We know that this is going to be 5 moles of strontium 2 plus and 5 moles of oxygen 2 minus. But it wants to know exactly how many ions are in the sample. So let's see, we're going to take how many ions? So 5 moles of SRO . This is one of those tricky questions where you don't know if they want just 10 or if they want, so in 5 moles of strontium, for every 1 mole of strontium, we have 2 moles of ions, basically. So we have 10, and if we want to start, and we say in 1 mole of ions, we have Avogadro's number. Our answer there could be 10 in terms of moles of ions, or if they want actual counted numbers of ions, then you're going to take 10 times Avogadro's number. So to answer a question like that, you could say it either way. Like if it's free response, you say there's 10 moles of ions, because if there's 5 moles of strontium oxide, you get a strontium ion and an oxygen ion. So you get 2 ions for every 1 strontium oxide. So we can say there's 10 moles of ions, or we can say there's 10 times Avogadro's number of actual individual ions. All right, so let's see. So you should be able to do, and again, I can provide a key for this later. How about, let's try number 8. That's a different one. So scroll down to number 8. It's on the last page of that one. Do we still have a few people on, or are people bored to death and they're already off? No. Okay, number 8. What mass of copper atoms have the same number of atoms as there are in 4.21 grams of silicon? Same number, so we need basically moles, mole to mole here. So 4.21 grams of silicon, we need to get that to moles. So in 1 mole of silicon, I think there's 28 grams. Number 14, Zach. Number 14 silicon is at 28.086.
Yeah.
Okay. So we're going to get a number of moles here. We want the same number of atoms. We're going to get the same number of atoms from the same number of moles. We're going to get the same number of atoms from the same number of moles. So we're going to take 4.21 and we're going to divide by 28.086 and we get 0.149, we'll say 0.150. 0.150 moles. So we need this, we have this many moles of silicon. We need that many moles of copper to figure out the mass of copper that will have the same number of atoms. So we're just going to take 0.150 moles of silicon, or no, we'll change that to copper. And just find its mass. I'm going to say for every 1 mole of copper, mass of copper is 63 something. Number 29, 63.546.
Yeah.
Okay, so you're just going to multiply 0.15 times 63, and that's going to be your mass of copper that will equal the same number of atoms as 4.21 grams of silicon. So we want mole to mole there. The same number of moles are going to have the same number of atoms, but of course their masses are going to be different because they have different densities. They have different numbers of protons, neutrons, and electrons. Okay, so let's go to the next sheet, which is B, O1B. You see one? Yeah, it looks like that. Okay. We have a grid there. So he writes, looks like the isotopes are written a little bit differently. And we've got row 1, we've got, looks like this, 13C, and then the 6 is over here. Normally we would have the 6 over here. You would normally have seen it in line with the 13. But anyway, the atomic number here, this is carbon, okay? So the atomic number is 6. The number of protons is the number, it is the atomic number, so that's also 6. The number of neutrons is going to be 13 minus 6, so that's going to be 7. And then the mass number is your 13. So that's how you would fill that out there. Now, let's do row 2. Row 2, we're told the atomic number is 17. If the atomic number is 17, that tells us what it is, and it's chlorine, yeah. That tells us that it's chlorine, and that's the atomic number. So the atomic number goes here. It tells us the number of neutrons is 18, okay? So we're going to add 17 plus 18 for the mass number. So 17, 30, it's going to be 35. 35 is our mass number. So the number of protons is the atomic number, and then the mass number is 35. So that's how you would fill out those grids there. You can do that. You can answer those. Naturally occurring. Okay, so E, if you jump down to E, naturally occurring nickel is found to have the following approximate isotopic abundance. Calculate the average relative atomic mass to 2 decimal places. So you're just going to take all of these. This is number E, of worksheet B on isotopes and mass spec. So I don't need this one right now. So this is E, and we have, looks like this, we have 58, we have nickel 58 is 68%. We have nickel 60 at 26%. We have nickel 62 at 4%. And we have nickel 61 at 2%. So we want to know the average. So we're just going to take all of these and add them up. We're going to take the mass number by the percentage. So we're going to take 58 times 0.68 plus 60 times 0.26 plus 62 times 0.04 plus 61 times 0.02, and just add all those up. That's all you do. So just multiply, add them up. That's the number. Don't take the this is the average. We already have percentages. So something that students get mixed up on is they'll do the math here and then they'll divide by 4 again because there's 4 items. Don't do that. We already have the percentages. So just multiply these and then add them up. That's your average. Okay? So let's see what's on page 2 here. I haven't looked at this yet. The results taken from a mass spec of chlorine gas show peaks at 35 and 37. 77 to 4 sig fit. Well, that's okay. So again, for here, for 2A, this is on worksheet B. This is reviewing unit 1. You're going to take 35 times 77 times 775 plus 37 times 0.225. You can deal with the sig figs, but that's all you do. Multiply this, get this product, and then add them together. And that's so just all the possible masses of Cl2 when they're made up of 2. So if all we have are 35 and 37, okay. So this is for B. If all we have are 35 and 37, when chlorine bonds to chlorine to make Cl2, then basically what are the combinations here? We could have 35 and 35. We could have 35 and 37. This one could be 37 and this one could be 35. But that's going to be the same mass. Or we could have 37 and 37. So what are the possible masses? Well, 70. This would be 72. And this would be 74. Those would be the masses. Now, if they want it to be even more precise, where we're taking 35 times this, yeah, no, I don't think they would do that. So I think this is what you would look at there. We'll see if they agree when we look at the key, but that's how I would do B right there. Which would be the most abundant? Well, the most abundant would be the one. So let's do this. Let's finish, or let's do the math for A, and we're going to say we have 35 times 0.775, and we're going to add to that 37 times 0.225, and we get 35.45. 35.45, and if we have two of those times 2, we get 70.9. 70.9. So basically, which one of these numbers is closest to 70.9? Well, it's closest to 7. This is closest to 71, but 71 isn't a choice, so we would say this one. So we'll see if we're right.
You had 2 people say hello.
Oh, hello. Greetings. We'll see if we're right when we look at the key for this here. Okay, page 3. Naturally occurring bromine, Baker, what is the average atomic mass? Okay. Have any questions come up? No? What are we running at here? 20 minutes? How long have we been running?
32.
Since the beginning? Okay. All right. So what I think I want to do is end it here in terms of what I'm working out, so that I can give you a chance to work these worksheets. All right. And then we'll have a Q&A. So I think we'll do a Q&A on Thursday, and I'm going to need to look at the timing of it. If it's going to be because there's AP sessions, and Mr. Dingle is having sessions. So if you're tracking either of those, I don't want to conflict with those. So I will send out I'll think about the scheduling, I'll look at what times those are, I'll send out a remind, but we'll have our next session on Thursday.
Not tomorrow?
No, not tomorrow. So what I want you to do is do as many of these worksheets as you can, work through as much of it as you can. Obviously none of it's for a grade. If you know, help everybody stay connected. If you have, there aren't very many people on right now. I've got about 30 maybe in the Google Classroom, which means the majority aren't in there. I'm finding out that some people aren't even on Remind. So, we got to get all this sorted out to get everybody connected. But bring your questions. I may or may not have the key distributed to you by Thursday. So bring your work as much of these as you can, and bring your questions on Thursday, so that I'm responding to what your needs are. All right. So I think that's it. Stay calm, be clean, do some chemistry. Do we have any questions we need to answer? No? All right. Well, again, wish we were face to face. Wish we could do this in the classroom. But we'll do the best we can. All right. Have a good one.